Okay, so hello and good afternoon. Welcome to this very important day when we have the pleasure to have our alumni back to home. So I am Miki Banu. Probably some of you may know or not. As we know, Professor Diane Bry ended her term as a chair in June, and starting July, I step in as a faculty director of ISD. And toward our great future, we are working together to build and to continue our success. So today is about celebrating our university, our college, our division, our people, and welcoming back our alumni. Please join me in showing them our appreciation. Let's give a round of applause. So let's take this time to connect with old friends and make new friends. And take the chance to say hello to everybody around you and create connections. These are very useful for your future careers. So, for the students who haven't graduated yet, um, we have here a lot of examples and role models, but today they will show you how to be successful after graduation. So, um, we are here to serve you, and we are here to listen to you. We are here to help you in any endeavor you have. And no matter what happened with new events in our life, we are always here in your corner. As we are today, we are welcoming again our alumni. Please join me in recognizing and thanking our dedicated faculty, staff who supported and provided all the nice organization of this event. Let's give them a round of applause. All of you play a very important role in shaping and supporting the academic environment enjoyed by our students and alumni, and your positive and powerful impact is so much appreciated. At this time, I'd like to introduce Dr. And Professor Kathleen Sienko, the Program Director for Design Science, and probably you recognize her. A round of applause. Professor Sienko will give us some remarks.
Good afternoon, respected alumni and current students of the Design Science program. Nigel Melville and I are thrilled to have such a unique and accomplished group of individuals back with us today to celebrate this homecoming event. Every one of you has been an important part of our community and has fostered growth and evolution of our program. It's a pleasure to see the diverse pathways that your careers have taken, and we are excited to see the future pathways that our current students' careers will take as well. The Design Science program at the University of Michigan prides itself on being more than just an academic curriculum. This program was designed as a visionary journey, covering topics from computational design to cognitive science, engineering design processes to human-centered and socially engaged design. It was constructed to foster creative leaders capable of integrating principles of design across various spectra. Over the years, our Design Science program has excelled in offering an interdisciplinary platform, proving its necessity in the cultivation of such a versatile and progressive field. More than 150 design science graduates have carefully crafted courses to create customized degrees and then accomplished remarkable achievements in various industries, academic centers, and government laboratories, integrating our design science principles in the pursuit of innovation and human-centered design solutions. Among you are leaders shaping the future of technology, healthcare, sustainable design, environment, education, and solutions to other multifaceted global and domestic challenges. Your success is truly our pride as a program. Your contributions have been invaluable, and your ability to merge theory and practice, science and aesthetics, business and environment continue to inspire our program and our next generation of design scientists who are with us today. We are proud and humbled to have such a powerful network of design science alumni, and we are excited to see what the future holds for both you and our program. So for our alumni, thank you for being not just a part of our past and present, but also our future. And welcome home, Wolverines. Thank you.
Thank you, Professor Cienko. And now it's time to invite Professor Judy Jean, who is the Program Director of Manufacturing. So, please.
Yeah, first, I did not prepare for such a formal speech, okay? I thought that we just like to welcome our alumni back to home and also report how our program is going on, okay? So just be short, okay? So as some of you know, our manufacturing program is the first program in the ISD. Originally, we called it Interpro, okay? And our manufacturing program not only offered Master of Engineering and also offered Doctor of Engineering. So for some of you, like you already got a master's degree from us and interested in further pursue doctor degree, welcome, come back to home to study further, okay? And also we offer several other programs, degrees, like a dual degree, manufacturing, also combine or collaborate with Rod Business School in the MBA as well. So you can benefit to get 2 degrees, save some time by sharing some credits, okay? And if your colleague or your friends want to say their kids in our UM, we also offer SAGAS program, sequential undergraduate and graduate program. So you can finish a master's degree within 1 year after your bachelor degree. Okay. We also have international collaborations. So we have University UM and Shanghai Jiao Tong University Joint Institute offer accelerated master degree program. Anyway, so I want to say give the opportunities no matter whether you or your kids or your friends. So ask them to tell them about our program, then we welcome to come here. So to report what is new in our program now, okay? So we are not only update our curriculum in traditional manufacturing, including production system and quality and advanced manufacturing. We also add or broad our manufacturing program in terms of advanced material, sustainability, and also recently we add more training on the emerging technologies such as additive manufacturing, smart manufacturing. So I hope those new blood people from our graduates later can also add it to your companies as work with our excellent alumni as well to make our program stronger. Okay. So finally, since you guys are also alumni, we also call for your help. Okay. So we have our capstone project. Our students really want to watch for some real industrial project, like work with our alumni as well. So if your companies, your systems have some need or have some opportunities, yeah, please let us know to have internship and all those student capstone project opportunity. I will be happy to talk to you for the details. Okay, so finally, go blue. Yeah.
Thank you, Professor Jean. Now is time to invite Professor Bob Bordley. And Professor Bordley is Director of Program of System Engineering and Design. Professor Bordley, you are floor.
Welcome. All right. Systems engineering. Today's about football, right? Or this weekend's about football. Well, what's a football team? It's really an interdisciplinary team. You have a lot of different people there. You know, some basically, we're all very muscular. Some very tall. Some can run fast. Some can block. Whatever. They all have different skills, different specialties. So an interdisciplinary team. And the coach's job is to take that team and focus it on winning the game. But the coach is responsible for looking outside. He has to talk to the university. He has to look at the opposition, the team he's facing. He's responsible for looking outside and saying, all right, what do I need to do? What do my customers want me to do? What do the fans want me to do? What's the pressure on the university about? Everything else like that. And together with that, he needs to think about his team and say, all right, I'm going to basically come up with a strategy. This is what we're going to do. I like to think of that as this first part of the app. The coach looks outside, picks up feedback and says, all right, what are my requirements for this game? What do I need to do to win? So he basically uses that to comes up with a tentative strategy. And he first works it out at a high level, saying, all right, this is what I think I can do based on, I've got these players. I think this guy can do this. This guy's been a great runner, and so on. And so he puts together this tentative plan. But the issue is he can't simply just impose it top down. Have you ever been in a situation where someone says, all right, I figured out this, everyone do this, and you go off and do that, and you say, no way I can do that. Well, there's some thing here. You have to go to each of the players. And so each player basically has to think of, is this something I do? If I'm the quarterback. Am I at my best? Do I feel I can do that? Was I just injured? Is my leg injured? Can I run as fast as I need? Have to look at it. Can I actually implement my specific responsibility? If I need to run, if I need to play, if I'm my block, can I really do this? But it's not only the individual player, because what the quarterback does depends upon what other people do. Suppose the halfback doesn't block the quarterback, who's basically the cornerbacks who's going after the quarterback. Well, then the quarterback doesn't have clearance to throw the ball. So quarterback success depends on these other guys doing their job. Suppose the quarterback throws the ball and the wide receiver wants to catch it. Well, again, if they don't block the linemen who are coming after him, he's going to get tackled. He can't do his run. And so it's like each of them has to be able to be in the right place at the right time. We've all seen these games where basically the wide receiver just hasn't gotten far enough. The ball's thrown beyond him and the play fails. Or he gets tackled shortly afterwards. A failure of any part of those individuals is going to lead to a failure of the play. And so you see all these parts that need to be integrated to make that work. And of course, the coach can't figure out that all by himself. That's where he needs the team. It's not just top down, I, the wise coach, come up with it. It ends up being something that's thought of top down, bottom up, all in this very orchestrated kind of manner. And that, if successful, creates an executable play. And that's what system engineering is about. System engineering is ultimately about, we've looked outside, we've looked at our stakeholders and said, all right, this is what we need to do. And that can be hard sometimes, because sometimes the stakeholders are conflicting. We have a lot of different people who are conflicting and debating in this world ahead. But they pull that together. Need to say, all right, based on all these people with all their different agendas, this is the goal we can achieve. This is, we can agree on this. Then we go and break it down and say, can we actually do that at each of those layers? Can each of our players implement? Can they run wide receiver, make the run he needs? Can the quarterback throw the ball as far as he needs? Can the cornerbacks, be there fast enough to block anyone coming after the quarterback? Can they do all that? And can they work in harmony? That's systems engineering, basically. You develop the plan, you break it down to the individual level, where they try to see whether or not they can make that work. And then we slowly integrate it back together. We sync the people together to see how they work. And then we run the play. And then we have continuous improvement. And system engineering has done that, not just with football, but way back when with Powell, way back when even with the Manhattan Project, with a wide series of successes, and now in the automotive industry. It really is taking, people have tried to do this for centuries and centuries. And system engineering is a method, first built in best practices, now infused with a lot of science, which you'll see in this program, a lot of computer science and technology. There's a lot of risk analysis. There's a lot of marketing science breakthroughs in the past century. There's a lot of new breakthroughs in computer science and generative design. One of the things we introduced in this program recently in the past year is Magic Draw, a very rigorous and wide respected approach to trying to quantify things. We are basically going to create the mechanics and methods of innovation to translate the brilliance and skills of individuals into something, world-shaking discoveries. And of course, that's what our football team is going to do this weekend. Go Blue!
Thank you, Professor Bodley. And probably we have to solve a quiz now. What is the optimization of the system engineering, meaning football game on tomorrow, so that Michigan will win?
Yes. Great capstone.
Yes, it is. It will be a capstone project. Think about, and we wait for signing up to this. Now it is my great pleasure and honor to introduce our featured speaker today, Mandy Damon. Round of applause. Mandy is recipient of this year's ISD Distinguished Alumni Award, which will be offered by the College of Engineering tonight. We have a special dinner where Mandy will be awarded. So this annual award is a very important one. It is a recognition of significant achievements in the field of one of the ISD programs for the alumni giving their time and talent to future ISD students. Mandy is Chief Engineer of Autonomous Vehicles and I think electrification. We have some updates. So, top of the line at General Motors. Her expertise is in cultivating confidence, leadership, management, career transitions, and industry insight. And as we had some chat today, it is all about integration. And probably Mandy will explain you in details this. In 2012, Mandy earned a master in Global Automotive and Manufacturing Engineering program in GAME. And since then, she is developing a bright and very successful career at GM. Today, Mandy is here to share with us the source of the success and serve as a role model for our students to follow, engage with alumni, and also be successful and come back in other homecoming days and report us what bright achievements you have. Mandy, thank you for coming today, and we invite you to share your experience with us.
Thank you. All right, good afternoon. Good to see everybody. Thank you for having me. I'm honored to be here. As Mickey said, oh yeah, that's me. I'm not going to pretend to be Bob. I'm having a great day already. I'll say too, this is probably the most food that I've ate in one day in a long time, with getting to go to breakfast, now have lunch and dinner tonight. So thank you for that. I'm going to bore you a little bit with my career, and not because I want this to be all about me, but because I want to show you how incredibly applicable my studies at the University of Michigan were to what I'm doing every single day. And I'll share some of those examples. Are there any game students here? Nobody?
Game?
Yeah. All right. Any energy systems? Sweet. My husband did that degree program. So congrats to you. Well, thank you for coming. Let me walk through my 20-year career at General Motors. I started when I was 5. So that's how I have 20 years. I did start there when I was 18. When my high school, Dakota High School in Macomb, is where I first started taking engineering classes. First engineer in my family. My mom and sister are nurses. My grandpa and uncle actually worked at Ford. We were a Ford family for a while, as they were both electricians. But I started taking engineering classes and I loved it. And that landed me at Kettering University for my undergrad, where I got a bachelor's in mechanical engineering. I started at GM when I was 18 as my first co-op assignment and had a really unique opportunity to move all around product development. Graduated in 2007, which was not the best time to start in the automotive industry. Thankfully, had some unique opportunities in noise and vibration and working in the lab out there, made it through that, and then had an opportunity to start my master's right away. When we went bankrupt, it did get paused, so it took me a full 5 years to get my game degree, but I can say it was worth it. And the time that I spent applying myself at night to the program while working all day, I wouldn't do it any different. So just continuing, I know I've got a lot in the slide here with my experience, and I think Ted called me out for how many jobs I've had, but it's been quite a ride, and this is exactly what this degree can do for you. So I moved out of noise and vibration and went into a job in chassis and steering. I was right in my thick of my master's at that time, and that's also when I did my capstone project, focusing on our steering intermediate shafts and addressing a noise issue on them. Graduated from here in 2012, and then right around that same time had an opportunity to go back to the Milford Proving Grounds. That's GM's proving grounds, not too far from here where we do a lot of the development and validation of our vehicles. I've spent about half of my career there, and Milford always feels like home to me just because that's the true hands-on, nitty gritty. I was doing a lot of steering tuning and shock tuning and loved my time in vehicle development. Then I had one of my first leadership roles as the lead development engineer of the Gen 2 Volt. Anybody ever drive a Volt? Oh, yeah, great vehicle. I like to say I kind of like worked on EVs before they were cool. Like we were like kind of like the, weird kids doing the electrification thing before it was super popular. But that was a great intro into EVs, and that was overall a very well done vehicle. In that 2016 timeframe, I had 4 jobs. And that was a wild year, but there was a lot of transformation in the industry. GM had just formed our electric and autonomous vehicle organization. So instead of us being, the weirdos out developing these hybrid vehicles, it became very mainstream. And I got to be the lead development engineer of the Volt, then the Bolt. Then I moved into a program engineering manager role where I was scoping a purpose-built shared autonomous vehicle. That was a wild idea in 2016, but that's almost exactly what we're doing right now with the Cruise Origin that we're getting ready to deploy in San Francisco. And then I ended the year on the Bolt autonomous vehicle. These are the vehicles that are actually doing paid rides through Cruise, not just in San Francisco. They've expanded now to several other cities. About a year after that, I was kind of right place, right time, and became the chief engineer of the Bolt autonomous vehicle, and then moved back out to Milford, now as the director of vehicle dynamics, noise and vibration, and HVAC development. That was a pretty cool opportunity for me as things really came full circle. That was the job that I did my undergrad senior thesis project in. That was the group I hired into in 2007. Now I was back leading that team through yet another transformation as we were trying to figure out how do we move away from vehicle development and what we've always done with hardware and find ways to do that using CAE and virtual tools. When I was out there in 2007, we were saying, road to lab to math. Well, now it's real. And we've got this virtual by 2025 challenge where we're really pushing the team to figure out how can we do things virtually to increase speed as well as cost and take out the variation. It's crazy sometimes to think about on vehicles, we make a big decision based on one vehicle demo, right? How are we sure that that's robust for our customers? So that was a lot of the move in that role. And then I was asked, and I had a couple little ones in there too. My kids are 2 and 4. And when I came back from my son leave that I took when my son was born, I was asked to be the chief engineer for the Escalade IQ. Has anybody seen the IQ? Hopefully just recently revealed. All right. So this is based off the Hummer architecture, 450 miles of range. I could spend the rest of the day talking to you about it, but I'll hold. Certainly if you have questions, happy to answer. But I can share a little bit more about the IQ and what we're doing with that electric vehicle platform and where we see it going. So thanks for bearing with me through all that. Ted challenged me if I could do all of those without looking. I could. And then, I mentioned my education. I've had a lot of really cool opportunities over the years at GM too to do different leadership training. One of the best ones was this doesn't matter what the acronym was. We love acronyms, but I got to go around to the dealers, and that was great because it was very customer centric and figure out, we design vehicles sometimes in conference rooms, but what are our customers saying? What are our dealers saying? What warranty issues are out there? That was really cool, in addition to all the more standard leadership stuff. I live in White Lake, so not too far from here. Spend most of my week at the Warren Tech Center or at Factory Zero in Detroit, where we're building the Escalade IQs. And then I mentioned my little ones, and my husband, Scott, worked at GM for 17 years, just left as part of the voluntary separation package, and also U of M graduate. So he'll be with me tonight. So let's talk about what the advantage is to this incredible program and all of you working with the ISD, how critical it is. And I really enjoyed going back through my curriculum as well as just the website to look at. I didn't have that lens then of how am I going to apply this? But now looking back, it's like, holy cow, they knew what they were doing, right? And I said I could almost line up my calendar for the week and every conversation I've had to a class or, a project or something, going back to the mission of this. So integrative thinking, Mickey said this, we talked a lot at breakfast about integration, and that's everything. Something that we've, had to learn the hard way a couple of times at General Motors is we design vehicles for customers. We don't design components. They're not buying components. They don't care about how well this one part works. 30,000 parts in a vehicle, how well can we integrate them together? My Milford experience, that was so much of that, where it was, not just the suspension tuning and what we were doing from a valve perspective in the damper, but how does the steering work with that? What are we using for cradle mounts? How does this tire pressures and you name it, how does that whole package come together? And how can we offer our customers something that they really love and want to keep coming back for more? Systems engineering, this is, yeah. I think, we talked a lot about it, but not too different than like some of the integration too and how important that is. Quality engineering. I just had one this week where we have a steering noise right now in the Escalade IQ that we're struggling to figure out. And it's like, pull out the quality engineering tools, right? This is a perfect Red X project, DFSS, split the dictionary, start swapping parts, get after it. And those quality classes were so key to what we do. I was a DRE at the time that I was taking them, or a design release engineer. And I recall those quality engineering principles all the time, so applicable to the problems that we're trying to solve every day. Vehicle manufacturing, as mentioned, we build trucks, and most of my days, 4 to 5 days a week right now, are spent at our vehicle manufacturing facilities and finding ways to help enable them to be successful. If they're not successful, we're not. And all of the years and time that we spent designing, architecting this beautiful vehicle is for what? So being able to partner with them to ensure that we're as lean and efficient and sound as possible is key. Engineering leadership, kind of an obvious one. I, at the time, was not in a leadership role. I was very much an individual contributor when I was going through the GAME program. But when I think back to the project work and the classes and the presentations, and then certainly my capstone project, there was so much leadership training in that I'm using every single day now as the leader of this team. Innovative solutions, another one especially from the autonomous perspective. When I was the chief engineer leading the Bolt autonomous vehicle, it was just innovate on everything. And the big thing there is, how do you do that on the critical path? So you can innovate. And we talked about this one too. Research and development, excellent. If it never makes it in the vehicle, so what? And that's something that we've had to work really hard to bridge the gap on, is how can we work with each other and collaborate so that the great inventions that you're coming up with are solving the problems that we're seeing now on the execution side, or the problems that our customers are struggling with. Global mindset. We talked a little bit about DEI this morning, but more in the mindset of who we collaborate with and who our customers are, and the need to have that global mindset and the perspective that not everybody driving vehicles is a car guy from Southeast Michigan. And that's been one of the biggest challenges that I've had to overcome, and why this program is so good, because as you get to work in these diverse cross-functional teams, it's so real to what we're trying to do. And whatever that product is that you're working on, whether it be a vehicle or not, keeping that customer in mind, focusing on diversity in thought, using, global supply chain, and we sell vehicles in China, and making sure that their requirements and regulations are met. A lot of that I learned here. Societal impacts has become a really big one too, as we talk about autonomous as well as electrification. And what does this mean, EVs? Even, we're spending a lot of time right now tuning it used to be pedestrian friendly alert function, that PFAF noise, or now it's AVAS, and I forget what the acronym is, but the sound that an electric vehicle makes so that people around the vehicle know that it's out of park. That's something that we have to tune and make sure it meets the regulation, and is also pleasing to our customers that have to listen to it every day. And then the capstone project I talk a lot about, that was key, I think, in application to industry and what we're doing. So I shared a lot of my examples when we were going through that. But if I think about my current project and the Escalade IQ, we've got a lot of technology in this vehicle. And one of those systems or big integration things that I was just working on this Monday is we have power open and closing doors. We've done this on the swing gate a couple times. Our autonomous vehicle had this in case somebody left the door open. But now we've got the biggest, heaviest steel doors in the industry that we're trying to power open and close. And frankly, they're moving too slow and they're too heavy at the moment. And the customer interface is really not good. So this was something where, myself as a chief engineer, on Monday I had to host a meeting with, or I chose to because it's important enough to me, 3 other directors just to get after this problem that we're trying to solve. There's a director of the module that controls the doors. There's a director of the software that goes into the module. And there's a director of the doors with the actuators and the system that is architected to do that function. Well, none of them own the integration of that. And this is where I go back to, from the customer's perspective, so what? They don't care that each of those individual silos met their requirements. It's up to us to bring that together, come up with what is the right integrated solution so that the doors that we're talking about and very proud of, that they open and close the way our customers need them to, and it meets the needs of their daily life. So I just share that as one example of many of these high-tech, complex solutions that need to be well integrated through everything you're learning, systems engineering, you name it, that we cannot just continue to work in our own silos. And I think that's what this program does so well. Brand equity and Escalade quality. This has, again, been big from the Escalade name has a ton of brand equity. People that buy Escalades are very discerning customers. They've spent a lot of money on this vehicle. They expect it to behave in a certain way. How can we use all of our quality tools that we have to make sure that it's meeting their needs and expectations? I talked about, launching in the plan and what that means and how helpful it's been, even though I've been very mechanical engineering heavy, to have that manufacturing mindset and understand their challenges so that I can work with them. The cross-functional leadership. I talked about innovation on the critical path and how important that is. And to me, that means, when I say critical path, that's a vehicle launch timeline that we used to do in about 4 or 5 years, and we've shrunk down significantly. So now it's how can you use those innovations and make that technology meet that timeline so that we can deploy it quicker and not have these big lags in what we're introducing to customers that feels like we're falling behind every other industry because that vehicle development timeline is so long. I mentioned, global supply chain, region of sales, some of the societal impact and what we're doing. This vehicle, 450 miles of range. It's also leather free. So overall, the sustainability story is very positive on this. And then the timeline that I mentioned. So that was a lot of talking. Hopefully it made sense. And some of the examples you can kind of see and think about your own classes and how it might apply. But now I'd like to open it up for any questions you may have.